So we're continuing our whirlwind tour of Python data types with dictionaries. Dictionaries are also called hashes or associative arrays in other languages, and they're a collection of key-value pairs. So you can create them with the dict command. That's sort of a pattern with all of these data types, as there's a command like that, or a function like that, I should say. And you can also use curly braces, although unlike a set, you have to have a colon character to separate the keys from the values. And so I have an example here where 1, 2, 3, 4 is a set, but 1, 2, 3, 4 is a dictionary. Now, the keys in a dictionary have to be unique, but the values can be of any type and they can be the same. They don't have to be unique. And the lookup on a key is a very fast operation in Python. So we have an example here of a dictionary called elements, which maps the symbol for that element to the name. So H to hydrogen, He to helium, Li to lithium, Be to beryllium. You can add to a dictionary by using square brackets, but instead of a number, in this case, we're considering the key to be the unique thing that we're setting. So elements B equals boron will add that to this dictionary. Now we can also get values the same way. So we can do elements square bracket H to get the value associated with that key. We can also do operations like in to look at the keys. We can list all of the keys or values or items, which is keys and values. And then we can do things like .get, which is similar to this operation with square brackets, except it allows us to specify a value if it's not found, if that key is not present in the dictionary. So dictionaries are very powerful. So I'll go ahead and run this. So the element whose symbol is H is elements H, which is hydrogen. C in elements is false because there's no C as the keys here. The symbols are elements.keys, H, He, Li, Be, B. We could also change this to values, and that would print out the values associated with those keys or items to get pairs. And then this .get, we're looking for PO. That's not found in the keys, and so we get unknown. And so if the key isn't in the dictionary and we're not using that .get structure, we'll get a key error in Python. So if we try and look for elements n, and there's no n in the keys, we get key error n. So we'll learn about exception handling in the next lecture. So we have an exercise right off the bat here, which is an improvement to our hello world function. And it's to revise this hello world function so it can greet you in several different languages. So your function must accept one argument, which is the name of the language to use for the greeting, and that argument should default to some language if no value is given. So this is a nice use case for a dictionary. So we want to add an argument to this hello world function, and we want to say language, and it should have a default value, let's say English. So we want to print out some text depending on what language is. And so I'm going to create a dictionary called greetings, and I'm going to say English, hello world, and then maybe French, we'll do bonjour. All right. So now let's try printing out the text based on whether this is found in the dictionary. So let's print greetings.get, which we've seen before, which will allow us to print out a default value of language. But if that's not found, then let's just print out greetings in English. All right, so we need to call this function, let's say hello world. With nothing, we get hello world back out. If we say language equals French, we get bonjour. And if we say something that's not found, we get hello world. All right. So there's a more complicated exercise here, which is a bioinformatics exercise translating DNA sequences to proteins. And so this puts everything we've learned together into one exercise. We have functions, we have strings, we have modules, we have dictionaries. So there's a mapping between the 4-letter alphabet of DNA, A, C, G, and T, to the 20-letter code of amino acids that make up proteins. And 3 consecutive letters, or a codon, in DNA maps to a single amino acid letter. So for example, ATG in DNA maps to the amino acid letter M. So using the provided module genetic_code.py, which defines the genetic code as a dictionary named codons, write a function that translates a DNA string to its amino acid sequence. So the first thing I'm going to do for this is I'm going to go look at this file, genetic_code.py. And so sure enough, we just have this variable codons, which is a dictionary mapping 3-letter sequences of these DNA letters to an amino acid letter. And so I'm going to use my import statement, and I'm going to import genetic code. And then just to check, I'll print genetic_code.codons. And now that's kind of long to type. I don't want to type that every time. I know I'm not going to have my own variable named codons. So I'm going to say from genetic code import codons. All right, so that's just a little bit cleaner for this project here. So now what we want to do is we want to loop through our DNA sequence in 3s. And so this is a good use case for maybe choosing the step size for a for loop in a range. So we could say maybe for index in range length of DNA sequence, we want to start at 0, and maybe we want a step size of 3. Then let's print index. Whoops. We need to run this code first. Okay. So that's going to go 0, 1, 2, 3, 4, 5, 6. So then we can say that our substring, or our 3 letters, maybe, I'm not going to be using technical terms here, I don't know anything about biology, would be DNA sequence from index to index plus 2. And I say that with rising intonation because it should be plus 3. And again, I'm not really like trying my best to understand that at every step of the way. I just try it and see what works, and that's a really common way for debugging things in Python and creating new Python code. So now we have our letters here, and we can get the corresponding amino acid letter from this codons dictionary. And so I'm going to naively assume that they're all present in this dictionary as keys. And so let me say amino acid equals codons 3 letters. Print amino acid. Okay, so it actually looks like they were all found. So we're pretty much good to go. We want to get a sequence of amino acids. So to me this says let's create maybe a string or a list. I'm going to say amino acid sequence equals an empty string, and then maybe here I'll say amino acid sequence plus equals amino acid. And so then at the end we should have our sequence as a string of characters, and indeed we do. And so the last little bit here would be probably creating a function for this. So we would say maybe def, is there a suggested name? Okay, just write a function. So I'll call this get amino acid sequence from DNA sequence. And then instead of printing this at the end, I will return it. And so then we could call print get amino acid sequence on DNA sequence. All right, perfect.